Let's take a look at this problem. There we go. A researcher wishes to estimate the proportion of adults who have high-speed internet access. What size sample should be obtained if she wishes the estimate to be within? Within is kind of a keyword for your margin of error. So they're telling us E is 0.01 with 95% confidence. Okay, now we'll get down to parts A and B here in a minute. Let's work with what we have here. So they give us E. Now 95% confidence. They're telling us that 95% goes in the middle here. Now all of this has to add up to 100%, which means we're going to split up the 5% into the tails. So we'll put 2.5% here, 2.5% here. Now 2.5%, if I put it in decimal form, is 0.025. So this is how it's going to look. Now what we need to find here is this is Z sub alpha divided by 2. This is our critical value. And to get that on our calculator, we're going to do INV norm. And looking at this line right here, we add up all the area to the left. The 0.025 and the 0.95, which gives us 0.975. Let's plug this in our calculator. So I'll do second vars. INV norm is third one. 0.975. Enter. This is the tricky part here. I'm gonna take it 2 decimal places. Sometimes the tricky part is actually writing it down correctly. Let's try it again. Okay. Sometimes what you'll... Oh, wait a minute, it is 9.6. Got sick over the weekend. I don't think I'm still quite there. Okay. The tricky part is, in some problems, to get it to match a by hand answer exactly, you have to take it 2 decimal places. Sometimes you take it to 3 decimal places. That's the tricky part. The only guideline I can give you is you take it 3 decimal places when your 3rd decimal place would be a 5. Okay, so we got that. Uses a previous estimate of 0.38. Now in A, previous estimate is referring to p hat. P hat is your previous estimate. So previous p hat is known. Now B says she does not use any prior estimates. So on this part, p hat is not known. So if they refer to a previous sample, previous study, something, then they're giving you p hat. Okay. Now, if you're given p hat, then you're going to use this formula. And if p hat's unknown, you're going to use this formula. So, p hat, or n is equal to p hat times 1 minus p hat, times our critical value, divided by E squared. And while I'm at it, let me go ahead and write down this formula. When p hat's not known, we got 0.25 times our critical value divided by E squared. Okay, on this one, we said p hat is known, if I didn't write it down. Previous estimate 0.38. So they're telling us p hat is equal to 0.38. So I'm going to have 0.38 times 1 minus 0.38. Z up here we said was 1.96. Excuse me. And then this is 0.01 and then squared. And let me go ahead and fill in the values here. Now Z is 1.96. Divided by E, which is 0.01 squared. Let's see, 0.38, beginning parentheses 1 minus 0.38. Should be a closed parentheses there. there. And beginning parentheses 1.96 divided by 0.01 close parentheses squared, enter. You always round up. No matter what your decimal is, you always go up to the next integer. So this one would round up anyway, but this would be 9,051. Now our other one over here, we got 0.25, beginning parentheses 1.96 divided by 0.01 close parentheses squared, enter. That's unusual. 9604. Usually you come up with decimals. Okay. 9051. And this one, 9604. The thing about using technology is up here I rounded this 1.96. If I had taken it to all the decimal places, we wouldn't have came up with the same answers down here, but our answers would have been more accurate than what the book or my math lab would give us, which is interesting to think about.